Hi guys, today we'll discuss about Turing machine basic concepts. So, a Turing machine is a mathematical model of computation, which means an abstract machine is capable of performing any kind of computation that can be described algorithmically. So, the Turing machine was proposed by Alan Turing in 1936 to formalize the concept of computations and determine what problems can be solved using algorithms. So this is a formal definition of Turing machines. Turing machine is defined as a 7 tuples, that is q comma summation comma gamma comma delta comma q naught comma p comma f, where the q represents the set of all finite states and the symbol represents the input set of alphabets. Here, the gamma represents the tape symbols, delta represents the transition functions, where we have the transition function is similar to our automata and push-down automata. So the Q naught represents the starting state, B represents the blank symbol which is present in the tape. Then F represents the set of all final states. These are the 7 tuples in the Turing machine. So next we have a components of Turing machine. So we have 4 components like tape head, state register, and transition functions. So here the infinite memory tape, that is a Turing machine tape, can be divided into number of cells. Each cells hold symbols from the tape alphabet, and the tape head is used to read or write symbols on the tape and move left or right. Then we have a state register. The state register is used to keep track of the current state. Then the transition function defines the machine's behavior. So what symbol we are going to write, which direction to move, which state to go next. So these are the components of a Turing machine. And next we have working principles. So here uh, in the initialization, you can place all the input strings on the Turing machine tape. Then the tape head reads the current input symbol under the tape head. So based on the current state and the or with the input symbol, current input symbol, you can use the transition function to write a new symbol, or we can able to overwrite the current symbol, and also we can move the directions, or you can move the tape head left or right. Then finally you can able to change a new state. So you can continue the steps 2 and 3 until reaching either accepting state or a non-accepting state. So next we have example. Here consider the language. The Turing machine for recognizing strings of the form 0 followed by 1, which means we have zeros followed by 1. So consider the language here, L equal to 0 1. So we can start in the state q0 with the input 0, then move right. We can change the state to q1. After reading 1, you can move right, then change state to accepting state. So then the Turing machine halt and accept the string 0 1. So this is the another example problem. So language consists of 0 power n, 1 power n. So where n is greater than or equal to 1. Here the input symbol should be 0 1 0 0 0, which means any number of zeros followed by any number of ones, and the goal is to accept the equal number of zeros followed by equal number of ones. We are using a cross approach here. So next we are tracing the input for 0 0 1 1, that is any number of zeros followed by any number of ones. We discussed the previous example. So based on that, we have now 0 0 1 1. So you can start at initial state q0, reading the first input symbol 0. We can replace the first input symbol with x and moving right direction. So the machine starts in the initial state q0. It reads the first symbol of the input string. The symbol is 0, then it is marked as processed by replacing it with x. Then the tape head moves to the right to find the corresponding one. So then in the step 2, we can move to first one, replace with y, then move left. And the Turing machine now search for the first unprocessed one from the first step. When found, it is marked as a processed by replacing it with y. Then the head moves left to turn to the remaining unprocessed zeros. Using step 3, we can repeat until all zeros and ones are replaced. Then the machine loops back to step 1, finding the next 0 to mark as x, then the next one to mark as y. This steps continuously Mm, this continues iteratively, ensuring every zero as a matching one. So if no unmatched, the symbol remains as it is. So once all symbols are marked, then the machine checks if there is any unmatched zeros or ones remain. The input string meets the criteria, and the transition during machine transitions to the goes to the accepting state. If any unmatched symbols remain, it goes to the reject state. So then we have types of Turing machine. One is deterministic Turing machine, another one is non-deterministic Turing machine. So in the deterministic Turing machine, we have no exactly one move for each state symbol pair, whereas in the non-deterministic we have multiple moves for every same pair. So the deterministic and non-deterministic both are equivalent in the computational power. These are the applications of Turing machines. Thank you.